Okay, so here are some exit problems for section 5. I strongly suggest that you attempt these questions on your own and then watch this video and listen to my explanations. I think you're going to get a lot more out of it that way. And yeah, so that's my recommendation. So to begin with, in this one, we see a composite function. Same thing, glancing ahead to number 2, we see composite functions. So not surprising that we're using this U substitution strategy. So in this problem, I'm going to take the inner part of my composite function. So I'm going to take u is equal to 3 plus t to the 7th. And I would do du. The derivative of that is going to be 7t to the 6th dt. Because remember, the derivative of u with respect to t, so du over dt would be 7t to the 6th, which can be rewritten as du equals 7t to the 6th dt. I don't have 7t to the 6th dt. I need that 7 in front of the t to the 6th in order to have 7t to the 6th dt. So that means I need to put a 1/7 in front. So this problem becomes 1/7 antiderivative of the square root of u times du, because I can pull out the 7t to the 6th dt, and that is my du, and I can put u in place of 3 plus t to the 7th. So this is just 1/7 antiderivative of u to the 1/2, and the antiderivative of u to the 1/2 is 2/3 u to the 3/2, because you add 1 to that exponent, and then the reciprocal of that exponent goes in front. So you're just about done. We just need to back substitute here. And so I have, looks like I'll have 2 over 21, and then u to the 3/2, so that's going to be 3 plus t to the 7th raised to the 3/2 plus c. So which one of these is it? Let's see. It looks like it is answer D. 2 times 3 plus t to the 7th to the 3/2 all over 21 plus c. Okay, let's go to number 2. We saw one kind of like this in the notes. But I think we actually had cosine in the denominator in the notes, and so in this case our u is going to be sine of s. I don't like that variable s in there, but we'll go with it. Du is going to be cosine of s ds, and that's exactly what we have. So this is kind of finally a case where I think it's the first time we've seen this where we don't have to modify the integrand at all. This is simply the antiderivative of, cosine of s ds is your du. And when that ds is written over on the side, I hope you guys know that that means the same thing as having ds up top. So when it's on the side, it's like multiplying by ds, or multiplying by like ds over 1. So it's like being written like this, where it's just cosine of s ds all next to each other, all over sine to the 8th of s. So we have du over u to the 8th, or this is the antiderivative of u to the -8 du. So add 1 to that exponent, divide by that -7, and then let's simplify. So this becomes -1 over 7. Oh, you know what? I'm not going to simplify it too much, because I actually notice as I'm going through this right now that the final answers are not simplified. So let me just go back and try to get my pen back. There we go. So let's just substitute in what our u is. And so we just end up with sine of s to the -7 all over -7 plus c. And so looks like that is choice E. We've got negative sine of s to the -7 all over 7. So instead of having a -7 there, they're taking that negative and putting it in the front, plus c. There we go. Okay, let's take a look at question 3. Question 3 says, find an equation for the function whose derivative is 7 sine of 21x and whose graph passes through the point pi over 21 comma -2/3. So essentially what this is saying is, let's find the antiderivative of this, but when you do an antiderivative, you're typically finding a general solution, and in this case, we're going to find a specific solution in the end. So it's going to be a little bit more work here, but we could do it. So let's set this up as the antiderivative of 7 sine of 21x dx, and we'll start with our u subs. Now, some of you might be able to tell me what the antiderivative of this is without even doing the u substitution, but I'm going to do it here. I'm going to say u is equal to 21x, du is equal to 21 times dx. Now I have 7 times dx, so in order to get 21 times dx, what do I need to modify in this integrand? I don't need to put 21 in here. I think I should multiply the integrand by 3, because that way 3 times 7 is 21 times dx. And if I'm multiplying the integrand by 3, then I can multiply it by 1/3 in front. Some students prefer to take that 7 out in the front to start, and then just put the 21 in there, and then divide by 21 in the front, but you're going to end up at the exact same place. So this is 1/3 antiderivative of sine of u times du, because 21 dx is my du, and 21x is my u. So sine of u times du. So this is 1/3 times negative cosine of u, and then we'll say plus c, or negative 1/3 cosine of 21x, and then plus c. And so this is going to match up. Oh, we have to find the specific c. That's right. So let's do that. So we'll say we're going to plug in our point, pi over 21 for x, negative 2/3 for y. So this becomes negative 2/3 is equal to negative 1/3 cosine of 21 times pi over 21 plus c. So you're doing the cosine of pi because the 21's cancel. The cosine of pi is negative 1, because cosine of an angle is the x-coordinate. The x-coordinate at pi on the unit circle is negative 1. So negative 1 times a negative 1/3 is a positive 1/3. When you take that positive 1/3, you bring it to the left side, negative 2/3 minus 1/3 ends up giving you c is equal to negative 1. So your answer to this question ends up being B, because we're taking our antiderivative and we're plugging in this specific solution for c. Okay, one more question here, number 4, a definite integral. So in this one, I see a composite function, so I would again let u equal 4z plus 5. That's the inner part of the composite function. My du would be 4 times dz. Do we have 4 times dz? No, we have 1 times dz. So let's multiply that by 4. But if I multiply that by 4, I need a 1/4 in front. And then when I rewrite this, I'm going to rewrite it as follows. I'm going to say 1/4 times the definite integral of, this is du over u to the 1/2. All right, my 4 dz can get taken out, and I can put du in its place, and I could plug u in for 4z plus 5. But I have to change my limits of integration. I like to solve these problems by changing, and so when z is equal to 4, u would be equal to, let's see, 4 times 4, that's 16 plus 5, that's 21. So u would be equal to 21. And then when z is equal to 6, you would have 24 and 5, so that's 29. U would be equal to 29. The advantage of doing it this way is now this is an entirely new problem at this point. So I would say I have 1/4, so I have to do the antiderivative of u to the negative 1/2. So I'm going to have to add 1 to that exponent. So that's going to be u to the positive 1/2. And I take the reciprocal of 1/2, which is 2, and that goes in front. And then we would say plus c. And don't forget to, whoops, I'm sorry, we don't want to say plus c here. This is not an indefinite integral. This is one where we are evaluating. So let's evaluate this going from 29 down to 21. So we have 1/4 times, this will be 2 root 29 minus 2 root 21. Notice that if you have 2 root 29 minus 2 root 21 all over 4, you can actually take a factor of 2 out of this. And so the simplified answer will be root of 29 minus root of 21 all over 2. And that is choice B. Okay, so I hope this helps tackle that 5.5 homework now, and let me know if you have any questions.